about, can you show me onions? So it looks like 1 and 5 and 4 were the most. If you had another one, Isaac, can you minimize that timer? Thank you. Okay, so 1, we haven't talked about this format, but we have talked about finding the range and domain and range. So once you know how to read it, it's a little easier. I think this one is actually open, but it's okay. So in this mapping, the left side is your x values, the right side is your y values. So if you're looking for the range, we're looking for just all the y values, and you would list those. But if I was looking for maybe to write them as ordered pairs, each arrow connects each x to each y. So this would be like an order pair, this would be an order pair, this would be an order pair, and that would be an order pair. Technically, the y, this 4 is in 2 different order pairs, but we would only list that in our range once.
Does it always go from greatest to great, or least to greatest?
Yes. Other questions on 1? Just the y's. Yep, for this one, just because it only asks for the range. Okay. And then for number 4, we are solving this equation. So we can start by distributing everything that's given. This is going to be -1. So this would give me -12x minus 6 minus 2x plus 6 equals 15x minus 20.
Wait, so there's an invisible 1?
Yes. So where that negative was, there's an invisible -1. Then we can combine that term, do exactly what it says, -12x minus 2x, and -6 plus 6. So -12x minus 2x gives us -14x. The 6's cancel each other out, become 0. We don't need to write that part. No, I realized I was like, it's working well. No, it's going to change colors like 50 times. Anyway. Okay, from here, we're going to subtract 15x. Let's see. So we get -29 is what this is supposed to be. 29x equals -20. And divide both sides by -29. So you'll end up with a fraction. I would just leave it as a fraction. X equals 20 over 29. You could. That's not what I'm going to do. Hold on. I don't know if I did that. So if I did that, put that in the calculator. It's going to give you some decimal, some not nice decimal, and if I try to simplify it, it doesn't simplify. So leave it as a fraction. Other questions on that one? Is it equals? It was, but the negatives cancel. Oh. Okay. And then for number 5, we're gonna add the perimeter or find the perimeter of this rectangle. You can do that a couple different ways. Remember that this is 4 sides, so include that on all sides, and then add all 4 in a straight line. Or you can use your perimeter equation. Have a good rest of your day. So I'm just going to use the equation because it'll make our lives a little bit easier. So if I know the perimeter is 2 times the length plus 2 times the width, I'm going to put both the length and the width in there. So let's say I'm saying the 3y minus 5 is our length. I'm going to put that in for L. And then if the 2y is our w, I would put that in for w. Then we could simplify. Can you go and click the middle button of the colorful options of that? Just click the white to the right.
Wait.
All the way to the board, the edge of the board. You see where the, yep. Thank you.
Wait.
And move it up. Yes.
Why did you do plus 2 and then parentheses 2
The plus 2 from the beginning. Or something else.
Yeah, but I don't know why you put plus 2 and then parentheses 2y.
So this plus 2 came from this. From the equation of finding your perimeter, adding up all the sides.
Do you add that in?
Say that again.
Do you add that in? Like in the
Since this is W. And then multiply. And then combine like terms. And if we had some value for y, we could actually find the perimeter, but because we don't, we're just going to leave it as 10y minus 10. And that would be our perimeter of this rectangle. Questions there? I'm going to show you guys your Delta Math. You guys had 3 Delta Math assignments that were due on Friday. So one of them was the multi-step equations. This one was informative, but informative does not mean don't do it, because it's great practice for your upcoming quiz and test. So make sure you are working on this and going back and practicing it. Oh, sorry. So the first one we didn't meet our 50% goal. The second one was formative, solving multi-step equations with variables on both sides. So make sure you go back and do that because that is not affecting your grade, but also good practice for the upcoming quiz and test. And then we also did not meet our 50% goal for the real rule problems. Again, formative, so it is affecting your grade. We need to go back and finish those, email me so that I can update your grade, but as well as practice those for your upcoming quiz and tests. Before we start what we're going to do today, were there any questions from any of those that we got stuck on, wanted to go over? I can pull that up. Yes.
I just didn't understand this one, the before.
Okay, so I can pull up one from yours. Okay, so let's say you get a problem like this. We'll read through it first and then we'll work it out. That's not good. So in this, Elijah works in a department store selling clothing. He makes a guaranteed salary of $500 per week. It is a paid commission on top of his base salary equal to 30% of his total sales for the week. How much would Elijah make in a week in which he made $775 in sales? So I'm going to disregard the second question. Just focus on the first one and break down the information. So 1, it's saying he's making this no matter what. If he doesn't make anything else, he's always going to make this, regardless. That's like your y-intercept, your one time or no matter what thing. Then he says on top of his base salary of 30% of his total sales. So that 30% is going to go with the amount of sales. And if he made this amount in sales, we would multiply these two numbers to figure out what that is, 30% of his sales, and add it to this. So in our calculator, we would do 775 times, we would change the 30% to a decimal, so 0.3. And we would add that to his guaranteed salary, the $500 per week. So that's what the first part is asking. 732.50. This over here though. So it's asking you to take those numbers and multiply, add them together, figure out what that would be. Then the second part, how much would Elijah make in a week if he made X dollars? So now instead of giving you some number, they're saying, how could I figure this out for any amount? So instead of that number, you're going to put X in. So what we did on our calculator was multiply this and 0.3. So that's where X would go. But I'm going to put the number first as 0.3X. And then in the calculator, we added, sorry, I'm trying to see which one that is. I think it's that one. Then we added 500. So to do that again, we would add 500 here. So it's asking for some equation expression, because it doesn't have the equals, of how I could find this in general. Questions on that? So all of these are very similar to the post office mail question and the car rental questions that we did for word problems when we did word problems. Make sure you're using your notes, double checking, all those things. Were there any other Delta Maths we wanted to see do go over before we continue?
What did it add to 232 to get 500?
We already had the 500. We added this and 500 together. Okay. So, as I mentioned earlier, your quiz is next class. Today is going to be the last thing we need to talk about, learn before your quiz next class. We'll review and then you'll take your quiz. And then the class after that will go over your quiz and then you'll take your test. So you all have a review. After we finish our lesson, you guys do the Delta Math. Then you guys can be working in that review and asking any questions. So look at those notes. So it's a little blurry, but I did want to point your attention to the learning target that we're rearranging formulas or equations to solve for a variable. So that's really important to keep in mind as we continue this. And then if I were to ask you, what is the difference between the following two sentences? It's raining cats and dogs and it's literally raining cats and dogs. What would you tell me? What about that? Wait, what was the question? What's the difference between these two
One is
sentences?
saying,
Brooklyn, go ahead.
one is saying it's raining cats and dogs, and one saying it's literally raining cats and dogs. So one can like be figurative and then one can be physical.
Okay. Anyone want to add to that? Go ahead.
One of them is what's it called, an idiom?
I'm bad with English.
Okay.
It's just a common sense.
Metaphor, okay.
It's like the first one is just like you think it's heavy, right? But the second one, literally is like it's actually raining cats and dogs.
So one's real and it's not.
Yeah. Yeah. So a mixture. Yeah. Go ahead. Yeah. So figurative, literal, metaphor, all of those things. Yes. Real and not real. So this one, it's raining so hard, it's like cats and dogs are falling from the sky. But this one, there are actual cats and dogs falling from the sky, which would be crazy. So some other little examples, it's kind of blurry, but this is, if you say I got your back, you don't have their spine in your hand, it'll be weird. So the actual word literal, it means actually or without exaggeration, but a literal equation, like in our learning target, is a formula or equation that involves several variables. And when we solve this literal equation, we solve it like a normal one using our inverse operations to rearrange the equation, but we're not getting an answer. We're not getting an actual numerical answer. So we actually literally solve the equation for this variable to get an equation. So it's weird. Look at the next page. Okay, so use these helpful hints if it helps you to figure out your next steps. I would say if all the different variables, use circle, highlight, underline, whatever variable it is you're solving for. Think about what you would need to do if this were a regular equation to solve it, to get the variable by itself by using your order of operations. Get rid of fractions by multiplying by the reciprocal, really. If this is like worst case scenario, if you get stuck, you could rewrite the equations with numbers and then in place of the variables and solve it, but then you still have to go back and put the variables in it, so that would create more work. So we're going to solve some regular equations, and then we're going to solve some literal equations so you can see kind of how we would do this. So for example 1, how would I solve this for x? Divide both sides by 2, so that we get some x equals 5, that is our answer. But now in example 2, we have gh equals m, and we're solving this equation for h. How could we get h by itself? Divide both sides by g. So that these g's cancel, leaving just h, and then equals m over g. I have no idea what that represents or means, but if I had numbers for them, I could put it in, and then h would equal m over g. Questions on that so far? Okay, on to the next. For example 3, how would we solve this for x? And then just like this first one, divide both sides by 2. So that x is 3. Now, similar, for example 4, how would we solve that one for x? Subtract b on both sides. And when we do that, b and c are not like terms, so I can't combine them, but I can rewrite this. So we have ax equals c minus b. And then to get x by itself? Divide by a. so that the a's cancel on this side, leaving x equals c minus b all over.
Do you have any questions on that one? Did you have a question?
How do you add over A?
We divided both sides by 8. Yes.
Why is it minus b? Is it because if it was like, for example, if it was like minus b in the equation, when we put plus b?
Yes. It's always opposite. Yes. Yes.
Okay, now we're going to do 5 or 6. I'll let you guys choose which one would you rather. Five or 6, choose.
Oh,
5, okay. We'll do 5. So in example 5, we have to solve this equation that now has variables and numbers. I'm just going to rewrite it. For x.
How do we think we would do that?
So I heard minus and you heard and I heard
plus
plus. Yes, so it would be plus, but not just the 6. This is connected. So I would have to add this whole term, the 6y, over. And also I can move that whole thing because it's not directly connected to x. I don't need to do anything with the y. I can get rid of it or move it by adding it to the other side. So we have 3x equals 17 plus 6y. And then, yes. Now, anytime you are dividing by numbers, if there's anything you can simplify, so like 6, I can simplify 6 and 3, divide those separately. Divide everything separately. So that we would have x equals 17 over 3 plus 2y. Then I can't combine those. Those aren't like terms, so that would be my final answer.
Questions there? Okay. 7 and 8 are very similar, but now we only have variables.
Let's say we're solving for 7. Or solving for c at number 7. How would we do that?
Think about what we just did. Minus what?
Well, if we're trying to get c by itself, I don't know if that would be our best move.
We could do that, but then we'd have to do other things with it.
We could subtract AB, get rid of this term because it has nothing to do with the CD. G and AB are not like terms, so we can't combine them. Just rewrite them. And then our last step. Divide both sides by 2. Correct. Thank you. Yes. Yes.
So then that final answer would be C equals G minus AB all over D. Yes.
On the question on top, why don't you divide 17 plus 6y like you did with g minus 8? You divide them separately.
Yes, because this 3 goes into 6. If this had been a 5 instead, then I could have done this. Because the 5 wouldn't go into either of these. But anything that's even, this will be simplified. Unless that goes something that would go into 17, you wouldn't do that. Okay, I want you to try number 8. If you finish up before we go over it, you can try number 6. If you need my help.
any questions on number 8? How many of us got that? If you didn't, it's okay. But I am glad that some of you are. Okay, go on to the next page. And I want you to find any of those you want to see do go over, have questions about. Three, okay. Any others? 6 and 4, okay. Alright, so starting with number 3. We have to get f by itself, which is inside parentheses. We could distribute, or we could multiply both sides by the reciprocal. Take it, flip it, and multiply. Which would we rather, distribute or multiply by the reciprocal? Okay, so if we distribute, we're going to end up with 5/9 for both. Go ahead and multiply 5/9 and negative 32. What do we get there? Then we have to get f by itself, so we gotta get rid of the fraction that has nothing to do with f, so add that to both sides. As you'll soon start to see, distributing is not always your best option. Because we still have to do the other option that I said. We still have to take this and flip it and multiply on both sides. And now we have to do that to this entire side. I'm going to write this like this first with it in parentheses. But you could also simplify that by distributing that back. So if you had started by multiplying by the reciprocal on both sides, you would end up with something slightly different, but I'll just leave that as that for now. Questions on that? Okay. For number 4, we have to solve for m. Yes? Why did we multiply 9/5 by both sides? We took this fraction, we flipped it, and we multiplied on both sides. So instead of dividing this by this fraction, which we could do, but that would be messy.
Also, you can cancel.
Yes.
So if quizzes or tests, are we gonna have to like solve the 9, whatever is in the parentheses and answer it, or do we just send it like that?
You could leave it like that.
Why did you solve it? Why did you solve it?
Why didn't I solve it? I don't really need to because I have f by itself. Anything else would just be more simplifying. I could do that. If I wanted to get rid of all the fractions, maybe combine some of them. Because what's going to happen is this is just going to become 32 again. And now this will have the fraction. In number 4, we have to get m by itself. How could we get rid of b? Multiply by b. Because if I multiply by m, that's just creating m squared, so we don't want that. But if I multiply by v, then the v's on this side cancel, and I'm left with v. But if I had to solve for v, what would I do? Because then we still get that m squared.
Find the
So if we had to find v instead, yeah. So we could do that. Isaac, what were you going to say? But all you did was just move v to this side, and now it's being multiplied with something else. So I don't think that would help you. Any other ideas? How would we solve that one for v?
Multiply those by
So that would just give you m squared. This is all that would do. That wouldn't help you.
multiply both sides by 3 and then divide by 8.
So this one, you actually have to get rid of the v first, and then get rid of the v on both sides by dividing. Or you could have cross multiplied. This is really a fraction. And then you would have ended up here and then divided. So keep that in mind. Okay. Questions on that before we do 5? In 5, how would I get b by itself? Yes, multiply both sides by d. We have AD equals B plus C, and then subtract C, yes. So we have AD minus C equals B as our final answer. 6 is very similar to 3, I think that was. We have to get B1 or B sub 1 by itself. It is inside parentheses. We have to get rid of the 1/2 and the H. We're going to do that in 2 separate steps. So we could distribute the 1/2 or we could multiply by the reciprocal. Which one would we rather? So take that, flip that, multiply on both sides. So we get 2a or 2a over 1. I don't really need that one. Equals h times b1 plus b2. That part is still in parentheses right now, but it will go away here in a second. Then I could get rid of the h. It's multiplying to this. So to undo that, divide. Now, because there's nothing outside of the parentheses, I can drop the parentheses. So that the last step would be
minus B2.
2a all over h minus b2 equals b1. Done. Questions on that one? And then look at the next page and find any questions you want to see. Do go over from there, and then I'm going to show you one last thing, and then you can have time to practice. One. Okay. same is similar to 5, so we're not going to do 5. Any others? So starting with number 1, we are trying to get t by itself. I and r and t are all next to each other, so they are all multiplying. So we can do the opposite and divide all of them at the same time. Not all, just I and r. So that the I and R cancel, and we're left with T over IR equals T. Questions on that before we do 4? In 4, we're solving for M. How would we do that? Multiply both sides by 2. We have 2k equals mv squared. What would be the next step? If we were solving for v, we would square root, but we're not. We are going to divide by what? V squared, yes. So that we get 2k over v squared equals m. That is our final answer. If we were solving for v, we would have divided both sides by m and then took the square root of both sides to undo the square. Questions on that one? Number 7 says a equals pi r squared. I draw my pi's like this. So if we're trying to get r by itself, what would be our first step? Divided by pi, yes. On both sides. Treat that like a variable even though it's a number. And then yes, then you would take the square root of both sides so that the square root and the square cancel on the right, just leaving r. Questions? So anytime you need to undo something that's squared, you take the square root, and vice versa. That's something we talked about earlier. For
So if,
yeah.
if there's no pi or square root, you're not going to use
If there's no, it depends on the problem what you're solving for. So like in the last problem, we didn't use the square root because we weren't solving for v. We were solving for m. But in this one, because we're solving for r is squared. The only way to undo that is the square root. Yes. In 8, what are we solving for? X. So if x is here, what should we do first to start getting x by itself? Subtract 3j. There's nothing to combine. We're just moving that to the other side. I'm just going to put that at the end. And then our last step. Divide by -4. Yes. If I divide, is there anything that would simplify with the -4? Yes. So that means I have to divide them separately. Now, the others are just going to change signs, but this one is just, the whole fraction is going to change. So this would become -9 fourths z minus, this would become 1/2 a plus 3/4 j equals x. if 4 had been a 5 instead, then we would have just divided the whole thing. Any questions on that? Okay. I'm going to show you an example of something you might see on Delta Math. So some of the examples, you might see something like this, where you are, let's say, solving for G, but in this case you have 2 G's. So in this example, you have to get the G's together. So think about it like if I had something in parentheses or something outside of parentheses, I would distribute that, and then it would be multiplied to both. I kind of want to undo that here. So I want to take that G out of both of them by putting it out front of parentheses, and then putting whatever is left. And if I'm solving for G, I'm going to get rid of everything inside the parentheses by dividing those on both sides. Yes. Yes. Yeah. So you might see something like this, or you might have something where maybe let's say MG is on this side, so you have to get it to the same side and then do this process.
Is it the same process for every single scenario like this, or is 2 the same version?
Yeah, for any scenario where you have 2 of the same variable, you're going to do that same sort of process. Did you have a question?
So, if it goes to the side where it goes to never to anything good, which is the second?
Yeah, this is that. Because we can't do anything with it. They're not like terms. Okay. Other questions before I let you practice? Okay, so do this Delta Math on literal equations, and then you guys can work on other Delta Math or your study guide review that's on your desk. You guys can work with each other, move around, let me know if you